more identities? What are we doing today?
Sorry, what was that?
Let me turn my volume up on my phone here.
Okay.
Okay, what'd you say?
Okay. Let's see. Okay. So, I think, let me just find something that I didn't do yesterday.
I tell you what, can you call me back?
Yeah.
Call me on, I'm going to hang up, maybe we can get a little better audio here.
Okay.
Go ahead and call me. Let me hang up
All right.
here first. Emma?
Mm-hmm.
Okay. That's a lot better, actually. I'm glad I suggested.
All right.
Okay. So what do we got today?
Okay. So, let's see. I'm just trying to find something that we didn't do yesterday.
Now, have you gotten to trig equations yet? Solving trig equations?
What are those?
I'm sorry, what?
Which ones are those?
Well, something like sine squared of x equals 3/4.
Yes, we have. And then, like, you use the Laplace.
Yeah, you solve it for sine x, and then you figure out where in your domain that it's equal to that value.
Yeah, we've done those.
Okay.
Let's see.
Those are a little different than verifying trig identities. In other words, a trig equation happens in the real world all the time. So you frequently have to solve trig equations in the real world. Trig identities, on the other hand, are strictly an exercise dreamed up by some math person somewhere to get you to learn your identities.
Right.
Their only purpose.
Okay. Let's see. So I have cosecant of theta equals -5/3, and then tangent of theta is greater than 0, and then it says to find the sine of theta over 2.
Okay. These two pieces of information allow me to determine everything I need to know.
Mm-hmm.
Let's ignore the question for the moment.
Mm-hmm.
What do I do based on this information here?
You figure out what quadrant it's in first.
Okay,
so
what quadrant is it in?
Cosecant is negative in the third and the fourth, and then tangent is positive in the third.
Okay, so it's got to be third quadrant, right?
Mm-hmm.
Okay, that's all this statement means. I don't need this anymore. It's
right.
Third quadrant. Okay. Now, I have one trig function. I know the quadrant, and they're asking me about another trig function.
Mm-hmm.
So, what's the first step?
Draw the triangle in the quadrant.
Exactly. That is always the first step in problems like this. Not just drawing a right triangle, but drawing it and labeling theta. If you don't label theta, you can't really proceed.
Right.
And now what can I do?
You can put 3 on the opposite, and then 5 on the hypotenuse, -5.
Well, I'm just going to leave it 5 because dimensions can't be negative.
Okay.
The only reason the negative, that tells me it's in the third quadrant. But in terms of figuring out all the other trig functions, I just need the dimensions of this triangle. What's the bottom base? What's the bottom dimension?
25 minus 9, so that would be square root of 36 or 6. Wait, no, sorry.
It's the square root of the hypotenuse squared minus the square of the other side.
Yeah.
So it's the square root of 25 minus 9.
The square root of 25?
It's the square root. Okay. If this is side A, side B, and side C, then B is equal to the square root of the hypotenuse squared minus the other side squared. That's the Pythagorean theorem. Okay, well in this case, that's 25 minus 9, or 4.
Okay.
That's a 3, 4, 5 triangle. Okay, it's helpful to recognize that. Look at how much time we saved by knowing that was a 3, 4, 5 triangle. I didn't have to go through the Pythagorean theorem, and I couldn't make a mistake.
Right.
Okay, so this is the triangle that they're referring to. That's theta. Now, what's the identity for sine of theta over 2?
Like the equation.
What's the half angle identity?
It's plus or minus the square root of 1 minus cosine theta over 2.
So, the thing we need from this triangle is the cosine of theta, not sine of theta. Right?
Okay.
In other words, if I can figure out the cosine of theta, I'm going to be able to figure out the answer to that, and that'll be my answer to the problem.
Right.
What's cosine of theta in this triangle?
4 over 5.
Okay, so let me go in here. It's the third quadrant, though.
So negative?
Correct. So negative 4 over 5. In other words, cosine of theta is 4 over 5, but we are in the third quadrant, so we do need to attach the sine to it. And is it plus or minus?
Would that be a sine as positive or negative in the third quadrant?
If I know that theta is in the third quadrant, is the sine of theta divided by 2 plus or minus?
Minus.
Not if theta is in the third quadrant. If I divide a third quadrant angle by 2, I'm going to be in the second quadrant.
Oh, okay.
Second quadrant, sine is positive.
Okay.
Okay, so I want the positive. Let me think about that for 2 seconds here. Yeah. In other words, theta is a third quadrant angle. It's over 180 degrees, less than 270.
Right.
Well, theta over 2 must be a second quadrant angle. If you divide the possibilities for theta by 2, you end up in the second quadrant. Somewhere between 180 and 270, half of that gives you 90 to 135. That's second quadrant. So I know my sine has to be the plus sign of this. So that allows me to erase the minus. And now, sine of theta over 2 equals the square root of 9/10. Which simplifies to 3 over the square root of 10, which rationalizes to what?
3 root 10 over 10.
And that should be your answer.
Okay. How did you get 9/10 out of square root of 1 minus all of that?
Okay. 1 minus a minus 4/5 is 9/5. That's the same as 1 plus 4/5.
Okay.
Divide that by 2, you get 9/10.
Okay.
So it's the square root of 9 divided by the square root of 10, which is 3 divided by square root of 10, which is 3 root 10 over 10.
Okay.
And it's got to be positive.
Okay.
Because theta over 2 has to be in the second quadrant, if theta is in the third quadrant.
Okay. Let's see. If sine of x is 5/12 and x is in quadrant 2, find the exact value of cosine 2x.
Okay. First step.
Draw the triangle because you know it's in the second quadrant.
Draw a triangle and label it theta.
Mm-hmm.
And dimension it as much as you can.
So opposite is 5 and then hypotenuse is 12.
What's this side? That's another perfect Pythagorean triangle. Oh, no, it isn't. Ooh, they tried to fool us here. Because 5, 12, 13 is a perfect Pythagorean triangle, but the 13 has to be the hypotenuse.
Okay.
Not the 12. So what's this side?
So it's 144 minus 25.
Right. Square root of...
Let's see.
119?
119, yeah.
Okay. So there's the triangle, fully dimensioned.
Mm-hmm.
And I can figure out any trig function of theta. So I have 3 different identities for cosine of 2 theta.
Mm-hmm.
Which one would I want to use? Do you have all 3 memorized, or are you looking at a page?
Yeah, she's going to give us a page, so we don't have to memorize them.
Oh, okay. Which one should I use?
Would you do one of the ones with sine in it?
Yeah, because I already know what the sine is. I don't have to do any math for this one.
Mm-hmm. So, oh yeah.
So it's 1 minus 2. Sine squared is 5/12 squared.
Okay.
So it's equal to 1 minus 50/12. Yuck.
Okay.
Don't like that answer. What's wrong with that answer?
You still have the 1 minus?
It's outside the domain. Cosines and sines can never be greater than 1, never be less than minus 1.
Okay.
That's at least minus 4. So I got minus 3 and change. I did something wrong. Let's back up. The other 2 identities are cosine squared minus sine squared.
Yes.
And 2 cosine squared minus 1?
Yes.
Let's try 2 cosine squared minus 1.
Okay.
I'm not sure why the other one didn't work. I must have made a mistake somewhere. What's cosine of theta?
Root 119 over 12.
Plus or minus? Second quadrant?
So it would be in the fourth?
Second quadrant. Theta is in second quadrant.
Oh, so you're not doubling it?
Not yet.
Okay. So,
I don't know what theta is. In other words, I never have solved for theta.
Right.
So I can't take the cosine of 2 theta because I don't know what theta is. The only way I can take the cosine of 2 theta is by using an identity.
Right.
Well, I know what cosine of theta is, right? It's this.
Mm-hmm. So it would be negative?
Well, no, I'm going to square it. So whether it was positive or negative was a little immaterial because I'm squaring it. And when I square it, I get 2 times 119 over 144 minus 1. That makes a lot more sense.
Okay.
That is a number less than 1.
Okay.
What number is it? Let's see. If we make that look like 72, and that's 72 over 72, it looks like 45 72s, which reduces. I can divide top and bottom by at least 3. 15 over 24, and divide that by 3 again, 5/8.
Okay.
That's what the cosine of 2 theta is. Now, let's think about that for a second. Is that sine right? Should it be positive?
Yes.
Yeah, because theta is in the second quadrant. If I multiply it by 2, I'm in the fourth quadrant.
Right.
So cosine of a fourth quadrant angle, which is what 2x is, a fourth quadrant angle, should be positive. Cosine is positive in the fourth. So our sine is correct, and we have a number less than 1.
Right.
So I'm not sure what I did wrong on the other identity using sine, but I probably just made a math error somewhere with the sine. I don't think that it's possible that one of these identities works and the other one doesn't. I think that was just accidental. In other words, I made a mistake the first time and I didn't catch it. Okay, what else?
Let's see. So 2 sine squared x minus sine x minus 1 equals 0. And then the range is 0 to 2 pi.
Okay. What are we looking at here? What else is that called?
Factoring?
It's quadratic.
Yeah.
It's called a quadratic in sine x. The only thing you need for something to be a quadratic is if the square of that term is that. You have a quadratic. Okay? In other words, this is a quadratic. Because this is the square of that term. Doesn't look like what you expect a quadratic to look like, but that's all you need for something to be a quadratic.
Right.
Now factor this.
So,
split that up.
So sine x and then 2 sine x?
What are your signs?
Are they both positive?
No, they have to be both opposite. You cannot produce a -1 with signs that are both the same. If both signs are the same, the sign on the constant is going to be plus. So if the sign on the constant is minus, the signs have to be opposite. Well, plus minus is sometimes the same as minus plus, but in this case it's not, because this is a 2, that has a coefficient of 1, so minus plus is going to be different than plus minus. So I allow for both of them. Now I only have one factor of 1. So either it's 1 and 1 or 1 and 1. That's my only choices. Well, does this produce the correct middle term?
It would be
Just multiply the insides and the outsides. You don't have to do the whole FOIL. Just multiply the insides and the outsides. Add them together.
So, yeah, the first one.
Actually, it doesn't. This produces plus 2 sine x. This produces minus 1 sine x. Add those together, you get plus sine x. So I get the right coefficient of 1, but the wrong sign.
Right.
Well, what that tells me is all I have to do is move that to the other side. Move it down to that. Now I'm going to get minus in the middle, plus in the back, and minus as the net.
Okay.
This one gives me the correct middle term.
Yeah, right.
And that's what you always have to solve for, is that make sure you have the middle term correct. Now what can I say? In other words, now I still have to come up with the solutions, but what's the next thing I can state?
One.
And
Negative 1.
now this one gives you negative 1/2.
Okay.
Okay. So those are the two solutions to the quadratic. Now we have to figure out what x is. In the unit circle from 0 to 2 pi, where is the sine equal to 1?
Pi over 2.
That's it. Where is the sine equal to negative 1/2? Let's find the angle first, and then figure out which quadrants we need to be in.
Okay.
So where's the sine equal to 1/2?
60.
Pi over 6, it's 30 degrees.
Oh, okay.
Right? Sine of 30 is 1/2. So which quadrants are we in? Are we talking about where the sine is equal to negative something?
Okay. That's the fourth and the third.
Third and fourth. What's the third quadrant angle that agrees with pi over 6?
7 pi over 6.
And the fourth quadrant?
11 pi.
There's your answers. Pi over 2, 7 pi over 6, and 11 pi over 6. All three of those satisfy that equation. So the biggest thing to recognize here is that this is nothing but a quadratic.
Yeah.
And you're going to see a lot of these if you're solving trig equations, because there's a lot of trig equations they give you that are quadratics. But notice that it didn't have to be this neat. What if I'd have said cosine of 2x? Now I got an equation that's got two different types of trig functions in it. Well, I would use the identity that had the sine squared only in it, so that I could turn this into a quadratic in sine x.
Okay.
If I use one of the other two identities, let's say I use this identity, now I don't have anything that I can solve. I don't have everything in the same trig function. In other words, I cannot factor that because I got cosines and sines. So you always want to end up with your quadratic being in the same trig function. Then you can factor it just like it was a polynomial. Notice that when I had this, I can actually use something called u substitution. I'm going to let u equal sine x.
Okay.
This now turns into u squared minus u minus 1. Well, I can factor that real easy. That's u, or there was a 2 in front. Where was the 2? Was it there? Yeah.
Yeah.
So it becomes that. So that becomes 2u times u. And let's see, that had to be minus 1 plus 1. So it becomes that. And now go back in and resubstitute for u. So you end up with 2 sine x plus 1 times sine x minus 1. In other words, if you have any problems at all figuring out how to factor that as a quadratic, just use these substitutions and make it look like a polynomial.
Right.
But once you get the hang of it and you do it a few times, I don't think you'll need to use the u substitution.
Okay.
All right, we don't have much time, but I got time for maybe one more.
Okay. Let's see.
If it's an easy one. I'm booked up solid today through 9:30, so I got very little wiggle time.
Okay, yeah, you're fine. Let's see.
Let me give you one.
Okay.
So what do you do here?
Sorry, my computer screen just went blank.
Oh. Yeah, it has you offline. Okay,
Yeah,
you don't need to see this. You don't need to see this. What I wrote was sine squared x equals 1. Write that on a piece of paper in front of you and solve it.
Okay. So, would you just take the square root of both sides?
Okay, what's the next line?
So sine x equals 1?
No. Sine x equals plus or minus 1.
Oh, okay.
Which means now x takes on pi over 2 or 3 pi over 2. So it's not like that plus or minus was just incidental. It gave you a second solution.
Okay, yeah, that makes sense.
Just always make sure when you solve an equation by taking the square root of both sides that you begin your answer with plus or minus. It's the hardest thing there is to teach my students. It's the most common mistake, most often repeated, most difficult for me to solve, for me to change. Everybody forgets the plus and minus. And notice, you know, if I forget the plus and minus there, then the only solution I get is pi over 2.
Right.
So I'm definitely losing points on a test if I put this down.
Right.
All right. So, all right, Emma. Let's see. Do we have anything else scheduled this week?
Nope, that's no last one.
That's it. Your final is tomorrow?
Yeah.
Good luck on it.
Thank you.
You're welcome. I'll have a Merry Christmas and Happy Holidays, and I'll probably talk to you next semester.
Okay, sounds good.
All right. Bye-bye.